We have some triangles here. Triangle ABC. In this triangle, all the angles are acute angle. This is a right angle triangle ABC, where angle B is 90°, and this is triangle ABC, where angle B is an obtuse angle. So we have three different types of triangles: acute angled, right angled, and obtuse angled. The point that we want to discuss is in any triangle, the sum of the lengths of two sides will be greater than the third side. Sum of lengths of any two sides will be greater than the third side. What does that mean? It means that if we take this side AC and this side AB, so sum of lengths of any two sides, AC plus AB, AC plus AB, AC plus AB. In all these three different types of triangles, the sum of these two sides will be greater than the third side that you haven't included here, that is BC. So AC plus AB, if you add, then the value that you will get will be greater than this third side. The value that you will get after adding AC plus AB, this value will be greater than the length of this side. AC plus AB, the value that you will get will be greater than this third side. You can make some other combinations. Now you can add AB and BC. So AB plus BC, AB plus BC, AB plus BC will be greater than this third side that you haven't included, AC. You can take another combination. Now you can take BC and CA. So BC plus CA, BC plus CA, BC plus CA is greater than the third side, that is AB. So this is true in any triangle, any triangle. Like here, you have triangle ABC, and here you have also triangle ABC. So ABC triangle is a larger triangle, and in both these two cases, you have a smaller triangle lying within this larger triangle. In this case, you have OCB. Okay. So even in this case, that is in this triangle OCB, the same property will hold true. So that means that if you combine OC with OB, that is OC plus OB, the value that you will get after adding them will be greater than this BC. If you add OB plus BC, this will be greater than OC. If you add BC plus OC, this will be greater than OB. Okay, so it doesn't matter what kind of triangle it is, this property that the sum of the lengths of two sides will be greater than the third side will always hold true. Okay, even in this case, triangle ABC is a larger triangle, so of course the sum of the lengths of two sides will be greater than the third side, that is AB plus BC will be greater than AC, AC plus AB will be greater than BC, and then BC plus CA will be greater than AB. Same thing will hold true for this one. So in this triangle ABC, if you add AD plus DC, this will be greater than AC. If you add AC and AD, if you add AC and AD, it will be greater than CD. AD and DC, it will be AC. The next will be DC plus AC, this will be greater than AD. Okay, same thing here in triangle ADB. So the point is, again, the sum of the lengths of two sides is always greater than the third side. So suppose if someone asks you that if someone asks you that, can you form a triangle with sides 5 centimeter, 3 centimeter and 1 centimeter, let's say. Okay, so the condition that the sum of the lengths of two sides should always be greater than the third side, always, is very important. Okay, whatever combination you make, that property will have to hold true, should hold true. So first add this two. 5 plus 3 is 8. Of course, it is greater than 1. So it's correct. Add these two, that is 3 and 1. So 3 plus 1 is greater than 4 and 4 is not greater than 5. It is not greater than 5. Therefore, you cannot form a triangle where the three sides will be 5 centimeter, 3 centimeter and 1 centimeter. Why? Because we just saw here, we can see here that if we are adding these two sides, then the sum of the lengths of these two sides is not greater than this third side, that is 5. Okay, let's take some other examples. Let's take, you are given 8 centimeter, then 2 centimeter and then 9 centimeter. Okay, is it possible to form a triangle having these three sides? Let's check it. First add these two. So 8 plus 2 is 10 centimeter, and yes, 10 is greater than 9, so it holds true. Now check for 2 and 9. So 2 plus 9 is equal to 11 and it is greater than 8, so this time it also holds true. Now add 8 and 9. So 8 plus 9 is equal to 17 centimeter, and yes, it is greater than 2 centimeter. So even in this case, it holds true. So yes, you can form such triangle where the three sides can be of lengths 8 centimeter, 2 centimeter and 9 centimeter. Okay. The second point, this was the first point. The second point is that if this is the property, the second property is if you subtract the lengths of any two sides, that will be less than the third side. Like in this case, if let's say that AB, in all these cases, AB is, let's say, is greater than BC, right? So if I subtract AB from BC, that is, if you try to find the subtraction of any two sides, that will be less than the third side, that is AC. Okay, that will be less than the third side, that is AC. So AB minus BC is AC, is less than AC. Then you can take another two sides, that is BC minus AC will be less than AB. Okay, same thing, if you subtract AB from AC, then it will be less than BC. The point is that you have to subtract a smaller value from a larger value. Since we don't know here which side is greater and which one is smaller, the only point is that if you find the subtraction of two sides, if you subtract a smaller side from a larger side, then that will be less than the third side. Okay, let's do some problems here. Is there a triangle whose sides have lengths 10.2 centimeter, 5.8 centimeter and 4.5 centimeter? First, let's solve for this one, for A. So what you have to do is, you have three values, 10.2, 5.8 and 4.5. We have solved some similar problems, right? Here we solve. Same thing we'll do here. First add these two. So if you add these two, 10.2 plus 5.8, this will be equal to 16, and 16 is greater than 4.5. Now take 5.8 and 4.5. So if you add 5.8 and 4.5, this will come 6.3 and this will be 10.3 and yes, it is greater than 10.2. Now take these two sides. 10.2 plus 4.5, this will be equal to 14.7, and yes, this is greater than 5.8. So yes, we can have a triangle of these three lengths. Let's solve for this one. So you have 2, 3 and 5. First add these two. So 2 plus 3 is equal to 5. And this is actually coming exactly equal to this one. But in order to get a triangle with these three with sides, this sum should have been greater than this third side. Here it's exactly equal. So it can't be even equal also. It has to be greater than in order to get such a triangle having these three sides. So no, this is not possible. Let's take for this one. You have 6, you have 3, you have 2. Add 6 plus 3, you get 9. 9 is greater than 2, it holds true. 3 and 2, so 3 plus 2, you'll get 5. 5 is less than 6. It is not greater than 6, so here we failed. So no, we cannot form such triangle. AM is a median of a triangle ABC. Is AB plus BC plus CA, AB plus BC plus CA is greater than 2 times AM? You have to prove this. You have to prove that AB plus BC plus CA is greater than 2AM or not. Let's do. So what you will do is, first, it's kind of fun to solve such problems. It's really very interesting. Take this triangle. If you take this triangle AMC, triangle AMC, in this triangle, if you focus on this one, AC, right? AC plus CM, since it is M is a median, it means that these two sides will be equal, right? So AC plus CM will be greater than this AM, right? This is a first equation. Okay. In triangle AMB, in triangle AMB, AB plus BM will be greater than this AM, right? This side AM. Whether you write AM or MA doesn't make sense. I mean, both are equal, same thing. This is second equation, not equation, but second thing. So if I add these two, so AC plus CM plus AB plus BM, okay, this will be greater than 2AM. Now if you're thinking that how we did this, let me show you with an example. Let's say that 5 is greater than 3 and 7 is greater than 4. Okay, that's clear. So if I do that, 5 plus 7 will be greater than 3 plus 4, and that will be true, right? Because this will be 12 and this will be 7. So of course 12 is greater than 7. So here we have AC plus CM that is greater than AM and AB plus BM that is greater than AM. If I add these two, then AC plus CM, then AB plus BM, it will be greater than 2AM, right? Like here we added, same thing we'll add here also. So this is greater than 2AM. Now, look very carefully. This AC is here, we have here, that is CA, AC or CA, same thing. Then you have AB here, you have AB here, but here you have BC. So if you look very carefully, the CM plus BM is what? CM plus BM is actually BC, right? Same thing. CM plus BM or MB will give you what? CM plus BM will give you what? BC. So from here we get AC, then plus AB, and if we group together CM and BM, then this will be greater than 2AM, and if you solve this, AC plus AB plus BC will be greater than 2AM. If you want to write exactly like this, so it's AB, yes, AB is here, then plus BC, BC is here, then you have CA, this is AC, CA or AC, both are same thing, okay? So CA, and yes, it is greater than 2AM. We have another problem here, and in this problem, ABCD is a quadrilateral, and it's asking whether AB plus BC plus CD plus DA, AB plus BC plus CD plus DA is greater than AC plus BD, AC plus BD. It's asking whether it's true or not. So basically it's asking that if you add all the sides of this quadrilateral, then is the sum is greater than the sum of the lengths of diagonals. So let's see. How will you proceed? What you have to do is first look at this triangle. Triangle BCD. Okay, first focus on this triangle. So from triangle, let me take some triangle BCD, from triangle BCD, you can say that BC plus CD is greater than BD. This is first one. Now what you have to do is focus on triangle ACB or ABC, this triangle. Let me take darker color. Okay, so you have to focus on triangle ABC on this triangle. So triangle ABC, AB plus BC will be greater than AC. Now focus on triangle ABD, this triangle ABD. So triangle from triangle ABD, AB plus AD will be greater than BD. This is 3. Now from triangle ADC, from this triangle ADC. So from triangle ADC, AD plus CD will be greater than AC. This is 4. If I add these 1, 2, 3, 4 together, similarly what we did in this case, so if we add them together, that is 1 plus, if we add 1 plus 2 plus 3 and plus 4. So add BC plus CD plus AB plus BC plus AB plus AD plus AD plus CD. So this was the addition of this left hand side of this greater than sign, and this will be greater than BD plus AC plus BD plus AC. That is, we have added the right hand side of this greater than sign. Now you can see here clearly that you have BC and BC 2 times. So BC plus BC means 2BC, right? Then plus, you can clearly see that you have CD and CD 2 times. Okay, so 2 times CD plus. Then you can clearly see that you have AB and AB 2 times. So 2 times AB plus. Then you can see that you have AD and AD, so 2 times AD. And this will be greater than, you can clearly see that you have BD and BD, so 2 times BD plus you have AC and AC, to 2 times AC. Now solve this one. 2 is common everywhere, so take 2 common. BC plus CD plus AB plus AD is greater than, 2 is common here as well, so AC plus BD. Okay, now 2 is here, 2 is also here, so it means that what, 2 is here and 2 is here, so it will be BC, it will get cancelled here, so BC plus CD plus AB plus AD is greater than AC plus BD. If you want to rearrange like this one, you can do it, right? Because we have proved it, we have finally reached that stage. First write AB, then write BC, then write CD, then write AD or DA, whatever it is given here, is greater than, AD and DA both are same thing, remember, is greater than AC plus BD. So AC plus BD. That's what we have to tell whether is it true or not. Yes, it is true, and we have proved this from these steps. Again, we have a quadrilateral ABCD, and in this case you have to tell whether AB plus BC plus CD plus DA is less than 2 times of AC plus BD. Okay, it's little bit different from here. In this case the addition is same, but now this greater than sign is less than in that case, and here it is 2 times AC plus BD. So we have to tell whether it is true or not. So to prove in this case will be a little bit different. To find, not to prove. Suppose this is point O where the two diagonals are intersecting. Okay, listen very carefully and watch it. This is the intersection point of these two diagonals. So if I focus on this triangle, this is triangle, let's say this is first triangle. So triangle first is ODC or OCD. From triangle OCD, what you can get, you'll get that actually CD is less than OC plus OD. Like it's similar to like OC plus OD is greater than CD, but I have just reversed their position, and what I have written is CD is actually less than OC plus OD. Same thing, that is the sum of the two sides is always greater than the third side. Now if I take this one as a second, so if I make it first, The second triangle is what? The second triangle is triangle OBC. In this triangle OBC, OC plus OB will be greater than BC, or in other terms, another term, we can say that BC is less than OB plus OC. This is the second. Now, if we take this third one, so third triangle is triangle OAB. In this triangle, OA plus OB will be greater than AB. In another terms, we can say that AB is less than OA plus OB. So AB is less than OA plus OB. Now, if we take this fourth triangle, that is triangle OAD, in this triangle OAD, OA plus OD will be greater than AD, or we can say that AD is less than OA plus OD, right? So this was the third one and this was the fourth one. If we add all these, 1 plus 2 plus 3 plus 4, add all them. So CD plus BC plus AB plus AD, okay, this will be less than, add all these right hand side things. So OC plus OD plus OB plus OC plus OA plus OB plus OA plus OD. Okay, now if we look here, then we can little bit arrange them and we can write them as AB, then plus BC, then CD, and this AD means what? DA only. It's less than, we have simply rearranged this sum, okay, of the sides. Now if you look here, OC is coming 2 times, so 2 times OC plus OD is coming 2 times, so 2 times OD. OB is coming 2 times, so plus 2 times OB, and OA is coming 2 times, so 2 times OA. Now if I solve it, this is AB plus BC plus CD plus DA will be less than, 2 is common in all of them, so 2 common, OC plus OD plus OB plus OA, right? Okay, this gives us that AB plus BC plus CD plus DA is actually less than 2 times. If you add OC and OA, OC and OA, OC and OA, if you add OC and OA, what you'll get? AC, right? This part plus this part means what? This whole part. So if you add these two, you'll get AC. Plus, if I add OD and OB, OD and OB, that is sum of this part and this part, will give you what? This whole part plus BD. So this will be AB. That's what we have to prove here, right? That's what we have to prove here. Is it true? Yes, it is true, because we have proved here. This is true. The lengths of 2 sides of a triangle are 12 centimeter and 15 centimeter. Between what 2 measures should the length of the third side fall? So the information that has been given to us is that you have been given 2 lengths of the sides of a triangle. Okay, one is 12 centimeter and another one is 15 centimeter. We don't know about the third side. Okay, we don't know what's the third side, let's say that that is x, you have to tell that between what two numbers, this value, this x will lie. Between what two numbers? Of course, there will be a upper end and there will be a lower end. Between these two numbers, you have to tell where x will lie. Okay, between what two numbers? So let's do it. You know that the third side will always be less than the sum of the lengths of two sides, right? So we know two lengths, that is 12 and 15. So 12 centimeter plus 15 centimeter will give you what? It will give you 37 centimeter. Your third side, the length of the third side will be less than this 37 centimeter by the property that we have discussed so far. That's for sure. Okay. If you remember, we had discussed that the second point, that is, if you subtract two sides, the length of two sides, then that will be smaller than the third side, right? So in this case, 15 centimeter is greater than 12 centimeter. So if you subtract 12 centimeter from 15 centimeter, that is, you are finding a difference of the two lengths of two sides, then this will give you 3 centimeter. And we said that this difference will always be smaller than the third side. It means that x will always be greater than this 3 centimeter. That's for sure. Whatever value of x will be, that will be for sure greater than 3 centimeter. Why? Because we discussed that the difference of the lengths of two sides will always be less than the third side. But if this is telling that your x will always be greater than 3 centimeter, this is telling you that your x will always be less than 37 centimeter. So the two numbers 3 and 37, between these two numbers, your x will lie. What will be that exact value? We don't know. Only we can tell about the two values or numbers between which this x or the third side will fall.